Hi, I'm member number 1. Today we are going to explain about how to conduct the experiment for the static friction on the inclined plane. We are going to use a website to help us to put some of the numbers inside and see whether it can move the object or not. I will explain the principle of this experiment. On an inclined plane, a static block will be start moving depends on two criteria, which is the inclined planes and the coefficient of static friction. The block is expected to move when the angle is larger, oppositely when the coefficient of static friction is lower. Next, we are going to test two things. The first is the friction. Is the higher friction or lower friction can move the object? The second thing that we want to test is the angle. Is the higher angle or lower angle can move the object?
Hi, I'm member number 2. We're going to test the task number 1. Just now, my friend explained about we change the friction and whether it's going to move the object or not. So we're going to fill in some of the value inside the website here. So we're going to check start from 0.9. After we have 0.9, the start and the object is not moving. Then we try 0.8 until 0.6. The object is still not moving. After we try 0.5, the object is start moving. After trying it many times, we're going to get number equals to 0.578. So the first value of coefficient of static friction when the block is moving is 0.577. Then we want to prove that is it this formula will become zero or not. After we put in the value and yes, it's become zero, and this one is greater than zero.
For table 2, status of block moving 0 degree until 21 degree, the block still static. From 24 degree until 30 degree, block moving. The last value of angle when the block still static, angle 22.7 degree. So just follow this formula, mg sin theta minus friction force equals 0. Next, the first value of angle when the block is moving, angle 22.8 degree. So just follow this formula, mg sin theta equal friction force more than 0. That's all for table 2.
If the mass of object reduced, is there any difference between the frictional force? First, for m is the initial mass of the object. Mg sin theta minus frictional force equal to 0. Mg sin theta minus static frictional force times mg cos theta equal to 0. So the static frictional force will be sin theta over cos theta. And for the reduced mass of the object, same as the formula, mg sin theta minus frictional force equal to 0. Mg sin theta minus static frictional force times mg cos theta equal to 0. So the static frictional force will be sin theta over cos theta. So there is no different static frictional force as it do not depends on the mass of object. If the object material change from wood to steel, is there any higher angle before moving? The static frictional force for steel is 0.74. So we use this formula, mg sin theta minus frictional force equal to 0. Mg sin theta minus static frictional force times mg cos theta equal to 0. Mg sin theta equal to static frictional force times mg cos theta. Sin theta equal to static frictional force cos theta. So static frictional force equal to sine theta over cos theta, which is also same as tangent theta. So we put the static frictional force in, which is 0.74 equal to tangent theta. So the angle will be 36.5 degree. As the angle of the incline decrease, the normal force and frictional force also decrease. Then I will pass it to my next member.
I'm member 5. I want to do the conclusion of our experiment here. After conducting the experiment, so we find that referring task 1, the critical value coefficient of story friction when the block is moving is 0.576. Second, referring task 2, we find that the vertical value angle of the plane when the block moving is 22.8. That's all. Thank you.